Hi guys, this is Mtoba. In this video I'm going to show you how to calculate the basic probabilities. I'm going to do question number 6.1. The group of 150 chief executive officers CEOs is tested for personality type. The following table gives the results of the survey. Personality type, we have type A and type B. Gender, men and women. So the notation of men is M and the notation of women is W. For type A is A, type B is B. Now calculate the following probabilities. The probability of type B. Suppose the question says calculate the probability of type B. B is the notation of type B. So the question says calculate the probability of type B. The formula is R over N. This is called the marginal probability. It is used when you are calculating a probability for one event. In this case, we are calculating the probability of type B. Type B is a single event. So we use the marginal probability. R stands for the number of favorable outcomes. The favorable event is type B. So the number of favorable outcomes, we are going to take the total of type B, which is the favorable event. The total of our favorable event, which is 53. Take the total. So it's 53 over N. N is the total number of possible outcomes. Total number of all possible outcomes, which is the total number of all favorable outcomes is 150. So 53 divided by 150 is equal to 0.353. 0.353. Presuppose the question says the probability of not type B. This bar means not this event. On the first question, we wanted the probability of type B. But here on question 2, this bar means we don't want the probability of type B. If we don't want the probability of type B, which means we want the probability of type A. But there's a formula to calculate that, which is 1 minus the probability of type B. We exclude from the total of the probability. The total of probability is 1. So we exclude the one that we don't want or we don't need from the total of the probability, which is 1. So we are excluding the probability of type B from 1. The probability of type B, we calculated it like this, which is 1 minus 53 over 150, which gives us 0.647. 0.647. Or just calculate the probability of type A, because if we don't want the probability of type B, which means we want the probability of type B, which is 97 which is the total of type A is 97 over all, or the total possible outcome, which is 97 over 150. So 97 over 150, it will give you the same answer, 0,647. It's either you calculate type A, since we don't want the probability of type B, or just exclude the event that you don't want from 1, which is the total of the probability. Now, let us go to the next question. Presuppose that the question says the probability of man or type A. The probability of man or type A. This probability is the union of events. The key word is or. This sign, which means or, and the counting rule is an addition rule. Now, in the union of events, before you calculate the union of events, you determine if the events are mutually exclusive or not mutually exclusive. Mutually exclusive means the events cannot occur at the same time, or there is no intersection. The formula when there is no intersection is Pm or type A is equal to Pm, which is the probability of man, plus the probability of type A. When the events are mutually exclusive, which is they cannot occur at the same time or they have no intersection. But man and type A have the intersection, which means they are not mutually exclusive. There's type A and there's man. So they intersect by 78, which means there is an intersection. So in this formula, we add this part, which is the minus the probability of man and type A. You subtract the intersection if the events are not mutually exclusive or they have intersection. So these two events, they intersect. That's why we subtract the intersection. If there was no intersection, our formula would have ended here. But there is an intersection, so you subtract the intersection. Now let us substitute the probability of males. The males are 120. Males, men, 120. Divide by all the possible outcomes, the total possible outcomes, which is 150. Then plus the probability of type A. Probability of type A. There's type A, so it's 97 over 150 97 over 150, then subtract the intersection. There's type A and there's man. They intersect by 78. So you write the intersection here, divide by the total number of possible outcomes, which is 150. Then the answer is 120 over 150 plus 97 over 150 minus 78 over 150. The answer is 0.927. 0.927. The answer is 0.927. 0.927. This probability is the union of events for not mutually exclusive events. Now presuppose the question says the probability of men or women. The probability of men or women. This sign here means or, and it is a union of events, and the counting rule is the addition rule. Now, before you calculate, you determine whether these events are mutually exclusive or not mutually exclusive. These events were not mutually exclusive because there was an intersection. Here, let us check if there is an intersection. Men and women, they do not intersect. They do not intersect. So these events are mutually exclusive. They cannot occur at the same time. So the formula is the probability of men plus the probability of women. So there's no intersection to subtract. Here we subtracted the intersection. Here there's no intersection because the events are mutually exclusive. They cannot occur at the same time. So the probability of men. So men are 120. Men are 120 over 150 plus women. Women are 30 over 150 total possible outcome. So the probability of men or women is 120 over 150 plus 30 over 150 is equal to 1. The answer is 1. So when your answer is 1, it is called you can say when you interpret these events are collectively exhaustive. These are collectively exhaustive events. Now the next question, presuppose the question says the probability of men and type B. This is a joint probability. Before you go further with your calculations, you need to determine whether these events are dependent or independent. Let us go and check men and type B. Men and type B. There's type B and there's men. So these events are dependent because there is an intersection. So these events are dependent. You use this formula R over N. This R is different now because you take the intersection of the events. Take the intersection of the events. Type B and men 42, they intersect by 42. 42 over 150. So the probability of men and type B is equal to 0.28. We want the probability of men that have the type B personality out of all the people there, which is out of all the chief executive officers. We want the men with the type B personality. So they are 42 out of 150. So their probability is 0.28. Now, presuppose the question says we want the probability of women and men. This is also a joint probability, but the difference is that these events are independent. There is no intersection here. These events are independent. So the formula, the probability of women multiplied by the probability of men. When there is no intersection or when the events are independent, you use this formula. The probability of women multiplied by the probability of men. So the probability of women, the women are 30 over 150 multiplied by the probability of men. Men are 120 over 150. The answer is 30 divided by 150 times 120 divided by 150. The answer is 0.16. 0.16. Now, please suppose the question says the probability of women given type A. This stroke here means given, which is the conditional probability. So the formula is PW and A, which is the intersection of women and type A, divided by the probability of type A. It's where they intersect, women and type A. there's women and there's type A. They intersect by 19 over the total possible outcome. Then divide the probability. Divide by the probability of type A. Total of type A is 97 over 150. So the answer is 0.196. 0.196. If you are a tertiary student, please round off up to 3 decimal places. But if you are a metric student, round off to 2 decimal places. I think my work here is done. Until next time, bye.